3.2. So remember with our correct topics, I'll put like an A or B behind it. So this is the first correct for section 3.2. 3.2 in college algebra is dealing with quadratic functions and the multiple ways of solving them. So we had already touched on factoring. So these 6 problems are just to remind ourselves how to factor. And then the back is a new way to solve. It's called the square root method, all right? So real quickly, before we jump in, it just says the quadratic equation is any equation that can be written as ax squared plus bx plus c equals 0, where a is not 0, because if a was 0, that would just be a line, mx plus b there, right? We need that x squared. So one method we can do is factoring. If you remember, it's called the zero product property. If a times b equals 0, then that means a equals 0 or b equals 0. So remember what we did was, if we know we have 2 things that multiply to be 0, one of the other things have to be 0. So we investigate and see, okay, which one could it be? So what you want to notice on example 1, already factored for you, right? We have one factor times another. So all we're going to do is set each of them individually equal to 0 and solve. So x plus 4 equals 0. And 2x minus 3 equals 0. And we'll solve those, right? So what's nice is when you get used to it, you can kind of just see that you're just carrying it over, so you're just changing the signs. So we'll have x equals negative 4 here. And then we'll have 2x equals a positive 3, so x equals a positive 3/2. Does that look right, guys? So what we did was we wanted to add the 3 over using the opposite operation, and we wanted to divide by 2 by using the opposite operation. So what does that mean? It means if we choose to plug in either negative 4 or 3/2, they're going to make one part of that 0, so then in the end they multiply to be 0. So 2, 3, 4, 5 are just us reminding, do we remember how to do the AC method, okay? So notice this is in quadratic form where it's x squared x constant equal to 0, so we don't have to re-scramble it or anything like that. So our A is technically 1. So what's our AC? Negative 12. So you can do the chart, or you guys start to get comfortable with factors. What are factors of negative 12 that add up to negative 4? 6 and 2, where which one would have to be negative if we're going to be a negative 4? The 6. Remember, the bigger factor always carries the sign of the middle. So we're going to rewrite this as x squared minus 6x plus 2x minus 12 equals 0. So remember, with the AC method, you keep your first term the same, the last term the same, and we're just splitting up that middle term into 2 factors so we can do factors by grouping. All right? What can you factor out of the first 2 terms? X. Pull him out. What are you left with? Perfect, x minus 6. What can you factor out of the back 2 terms? 2. And when you factor that out, what are you left with? X minus 6. Woohoo! That's what we want, right? So this is one ugly term, this is one ugly term, but what do they share in common? A factor of x minus 6. So you factor x minus 6 in front, and what does that leave for the front term? X, and what's it leave for the back? Plus 2. So now we've done all that work to just make it look like number 1, right? So we have the zero product theorem, or zero product property, excuse me, where we're just going to set each of those equal to 0 and solve. So we'll just set x minus 6 equal to 0 and x plus 2 equal to 0. So we have x equals 6 and x equals negative 2. Does that look right? And again, I know we don't ever really do it, but if you were to go plug this in and do all the math, 6 squared is 36. 4 times 6 is 24, so 36 minus 24 is 12. 12 minus 12 is 0. So we found these 2 values that when you go plug them in for x, they'll make it 0. All right, 3 is just a little bit harder. I like that it's all positives because then we don't have to worry about signs. So your A is 3, your C is 2, so your AC is 6. What are factors of 6 that add up to 7?
6 and 1.
6 and 1, right? So I'm going to write it as 3x squared plus 6x plus 1x plus 2 equals 0. Typically, we don't write a coefficient of 1, but I don't mind when you're factoring because you kind of see that 1 to factor out or whatever you want to think. All right, looking at the first 2 terms, what can you factor out of 3x squared and 6x? Not just an x, but also a 3, right? So we'll factor out a 3x, and we're not used to that because we're used to that x squared being the only thing. All right, when I factor out a 3x, what am I left with? X plus 2. All right, so when I go to these back 2 terms, I want x plus 2 left. And what do you realize about the back 2 terms? They are already x plus 2. So I put in air quotes, what do I factor out? I just factor out a 1, right? When the numbers are exactly what you want and you don't want to change a thing, you factor out a 1. If the numbers are exactly what you want but you want to change the signs, you factor out a -1. All right. Looking at this first ugly factor and the second one, they both have a factor of x plus 2. Pull him to the front, and what does that leave your second binomial to be? 3x plus 1, okay? So remember, you got to be careful. You got to show that this x plus 2 was here at one time. Because if you just put a 3x, that just factors to 6x squared plus 6x, right? Or 3x plus 6x. So you don't have that plus 2 anywhere. So what you have to realize is that when you factor it out, you say who he was there at one point. So who's your placeholder? That 1, okay? So we're going to set each of those equal to 0. X plus 2 equals to 0, and 3x plus 1 equal to 0. So we'll get x equals is a -2, and x equals -1/3. I'm kind of doing that skipping steps, guys. The first move you would make would be to subtract the 1 over, and the second move you'd make is to divide by 3. So I kind of skipped steps because I just didn't give us a whole lot of room. All right, so what I've been really bad about doing, and it hasn't hurt us yet, but the number one thing with factoring is to look for a GCF first. So notice like 1, 4, and 12, there's nothing we could have factored out. 3, 7, and 2, there's nothing we could factor out. But what about 3, 21, and 30? What can we factor out first? A 3. And that will just make it a little bit easier, because say you didn't notice that, you'd have an AC of 90. When your AC starts getting large like that, start saying, is there something I could have factored out in the beginning? So we'll factor out a 3, and that will leave us with n squared minus 7n plus 10. Does that look right, guys? So remember, when you factor out a value, you're just dividing everything by 3. So 3 would divide by 3 is 1, 21 divided by 3 is 7, and 30 divided by 3 is 10. So this 3 is going to be part of our answer, but we're only going to factor this part, okay? So let's look at this. Our A is technically 1. So our AC is a positive 10. I'm kind of running out of room. Factors of positive 10 that add up to a -7. 5 and 2, and what do we know about both of their signs? They both need to be negative. So we'll write this as n squared minus 5n minus 2n plus 10 equals 0. So looking at those first two terms, what can you factor out? An n, and you'll be left with what? N minus 5. Is that okay, guys? You see that? On the back two terms, we want the signs to be flip-flopped. We want the n part to be positive and the 5 to be negative. And right now our n is negative and the constant's positive. So what do we need to factor out? A -2. Another way to think of it is, I want n to be n, so who's in my way right now? A -2. So when you pull him out, a negative divided by a negative leaves you with a positive divided by a negative leaves you with a negative. Okay? So right behind my 3, I'm going to have my final factored form. All right? What's the common factor they have? N minus 5, but then what's behind it? N minus 2. And you set each of them equal to 0. Do you have to set the 3 equal to 0? No, because is there a variable, does 3 equal 0? No. Is there a variable to solve? No. But the reason why I kind of like to get in that habit is because if that was a 3n, we could solve it, you know? So don't always think your GCF has nothing to do with your problem, right? If there's a variable there, it most likely has everything to do with your problem. So he cannot do anything, but this will just be n equals 5, and what will this be, 2? All right, I think 5 is basically identical to that, guys, where if you did it, 6 times 8 is 48. Not the hugest thing, but notice that 6, 22, and 8 are all an even number, so what can we factor out? A 2. So do that, make it a little bit easier for you. So you have, divide everything by 2, so we'll have 3n squared plus 11n minus 4 equals 0. Does that look right? That 2 will be part of our final factored form, but we're not going to focus on him right now, okay? So what are factors of -12 that add up to 11? 12 and 1. And which one's positive, which one's negative if we need a positive 11? the 12 is positive, right? The bigger factor will wear the sign of the middle term. So we'll just write this as 3n squared plus 12n minus 1n minus 4 equals 0. And again, do you have to put the minus 1 in? No, but I want you to see those factors. 12 minus 1 is that 11 that we care about. 12 times negative 1 is that AC of negative 12. Okay, so what can I factor out of the first two terms? 3 and n. So we'll factor out a 3n. When we do that, the 3 divided by 3 is a 1. N squared divided by n just leaves us with 1n. Is that okay? And then 12 divided by 3 will leave us with a 4, and the n's kind of, we took them out, right? There's none left. Notice this back half, the values are what we want. We want an n, and we want a 4, but what do you notice about the signs? The negative, and we want them to be positive. So what are we going to factor out? A negative 1. You got it. So a negative divided by a negative is a positive, and a negative divided by negative is a positive. All right, guys. Our final factor form, they have that common factor of n plus 4 that can go right behind the 2. And do you guys get 3n minus 1 as your remaining binomial? Does that look right? All right, so then you just set each of those equal to 0. So 2 equals 0, n plus 4 equals 0, 3n minus 1 equals 0. 2 cannot equal 0 unless there was a variable there, but there's not. So we get n equals negative 4, and again, I'm kind of doing math quickly, 1/3. Is that what you guys get? Mm-hmm. You add the 1 over and divide it by 3. Yeah. All right, so our next example, we are going to do it with factoring, but I'm going to quickly show you how we don't actually have to factor it, okay? There's another method we can use. So we're going to do the same thing. Your A is technically 1, and your C is 25. So factors of negative 25 that add up to a 0x, right? We don't have that middle term, that 0x in the middle, correct? So what are factors of 25, negative 25 that add up to 0? Well, what's one of the only ways 25 splits up? 5 and 5, but if one's positive and one's negative, they cancel each other out. So we can write this as x squared minus 5x plus 5x minus 25 equals 0. Do you guys agree that x squared is x squared, minus 25 is minus 25, and technically those two middle terms cancel each other out, and that's what we want. But by writing it this way, we can do our factor by grouping like we've been doing, okay? So let's factor out an x, and what are we left with? X minus 5. What can we factor out of the back half? 5, and what are we left with? X minus 5 is what we want. Good. So these two terms have a common factor of x minus 5 that we'll bring to the front, and leaves us with x plus 5 for the back. So we're going to set each of those factors to 0 because their product is 0, and you get 5 and negative 5. And I think tomorrow, I don't know if we'll get to it today, tomorrow we'll even learn other rules about, that's called the difference of squares, if you remember. And you can actually just jump down to here, and I'll teach you that. It's the square root of the first, so what's the square root of x squared? X. The square root of the second, 25, so the square root of 25 is 5. And then the opposite signs make those middle terms cancel. Okay, so sometimes we can solve these when they're not even perfect squares, and that is called using the square root method, okay? So I think, Gavin, you've done this before, so you've obviously seen it in other math classes. Whenever your middle terms disappeared, so your single x has disappeared, and you're just left with x squared and a constant, what you can do is you can go about trying to isolate your x, okay? So if we wanted to isolate x, what's the first move we'd have to make? Add 25 over first, right? We'd have to move him over. So you have x squared equals 25. You guys agree with that? And then Riley, what you said is the next step, right? So how do you undo a square? You take the square root. What we have to be careful of, though, guys, is when we place that square root there, there's two types of numbers that end up squaring to be positive. Positives square to be positive, but negatives end up squaring to be positive. So how I write it is, when I place that square root over my x squared, I put a plus or minus on this side, because we know that x is going to be x. That's all we care about, right? So the square root of x squared is just x. But what's the square root of 25? 5, but negative 5. Exactly right. So I'm going to use the symbol, but right below I'm going to write it like that. You can do either or. And notice those are the two values that we just found on the bottom of the first page for example 6. We were able to factor it and solve, and we got 5 and -5. But that only works when it's factorable. This method will be able to work no matter whether it's factorable or not. We'll always be able to isolate whatever's squared, take the square root, and put the plus or minus in front of it. This plus or minus symbol is something that my math lab used to not have, but us as instructors asked and asked and asked, put a plus or minus symbol, because it gets tedious when we get to like the quadratic formula. So that symbol is actually there, and they should accept that. All right. Yep, sorry.
Why is there a -5? Because the square root of 25 is just 5.
Right, but I'm putting the square root there. So what we're really starting with is there's some number that when you square it, you get 25. When you square positive numbers, they're positive, but what other numbers can you square to come up with a positive? Negative. So if you just had the square root there, like if you just saw this, like if you didn't put the square root there, if they just asked you for the square root of 25, it would just be 5. There's no symbol in the front. But we weren't given that. We forced it to be that, right? So we're trying to work backwards, and so we're saying, okay, what number when we square it do we get 25? Well, 5 and -5 both square to 25. But if I just want to know the square root of 25 like that. So it's called, this one's called the principal square root when it's just the positive. But when we place the square root there, it can be positive or negative. All right, so that's all this is saying, guys. If x squared equals a constant, then x is either the positive of that square root or the negative of that square root, okay? So what we're going to do is we're always going to isolate whatever's being squared. So in this one, the c is being squared, correct? So what's the first move we're going to make to get it by itself? Subtract the 16 over. So remember when it came to solving equations, you move furthest away from your variable first, and you do the opposite signs. So c squared will stay c squared, 16 minus 16 will cancel out, and what's 25 minus 16? 9. So what we're doing is we're asking ourselves, what number can we square to get a positive 9? 3 or -3, right? So when we place that square root there, we need to put a plus or minus because there's two types of numbers that square to be that 9. A positive number and a negative number. Over here, the square and square root undo each other and it's c. Over here, the plus or minus hangs out as you break this down, but he's a perfect square. What's the square root of 9? 3. So guys, you can leave your answer like that, or if you want to see it so you know that it's two answers, you can separate it, okay? I sometimes like to write it this way so you guys visually see. There is two answers that when you square it and add 16, you get 25, right? Square -3 squared is 9, 9 plus 16 is 25. Square 3, 3 squared is 9, 9 plus 16 is 25. So this sometimes like hides the fact that there's two answers, even though that's what that symbol means. Okay, so we want to get this n squared isolated, guys, but there's a couple things we got to do first. We're going to move the stuff that's furthest away from us first, so that -8, how are we going to move them over? We're going to add them. Perfect. Okay, so 2n squared hangs out. These cancel, and what do you guys get? 24. Okay. Yes, I was going to say, act like it's just 2x, right? We want to get rid of that 2, so we'll divide by 2. So we have n squared equals 12. Is that okay so far? And then how do we undo a square? We take the square root, but we're going to put a plus or minus symbol in front of the 12. So far, we've dealt with perfect squares, 25, 9, but what do we know about 12? Is he a perfect square? Throw him in your calculator first to double check, and he's not, right? So what can we break 12 up as? What are any two numbers that multiply to be 12? 4 and 3. And why does that help us how you said it? What's the square root of 4? 2, right? So how we're going to write the final answer, guys, is that n will pop out on the left side. The plus or minus is still in front. Okay, because this 2 that pops out is part of that root. They're like connected. It's like his backpack, right? So the 2 will pop up and the 3 will be right behind it in the square root. That plus or minus symbol is in front of that entire thing, right? Because the square root of 12 is equivalent to 2 root 3. So if we want plus or minus that, we put plus or minus that in front. Some people want to put the 2 and 2 plus or minus root 3. I'm like, nope, it's multiplication. All right, last one. This is kind of a weird one. So we want to get this whole thing isolated, and we really want to get b isolated. But before we do that, let's just get b minus 2 isolated. So what's the first move we're going to make? Subtract 3. So we'll have 2, the quantity v minus 2 squared equals, is that 22? Is that look okay so far? What's my next move I'm going to make? Divide by 2. I know it looks weird, but we're going to divide by 2. So we get v minus 2, the quantity squared, equals 11. Okay? So we want to get v out, but where is he located right now? Still inside of a square. So how do you undo a square? You take the square root. So we're going to take the square root of the entire left-hand side. V minus 2, the quantity squared, is going to go under the square root. And then what do we need in front of our square root on the right side? A plus or minus. Okay? At this point, ask yourself, can 11 break down any? No, 11 is a prime number. It's just 1 times 11. So he's going to stay plus or minus the square root of 11. But what happens here, the square and the square root undo each other, so just v minus 2 pops out. And you're left with plus or minus the square root of 11. Is that okay, guys? So just like the square goes away with the square root with the n, the square goes away with the square root, but v minus 2 is still remaining, right? And what are we trying to do? We're trying to get v by himself. So what do we still need to do?
Oh, shoot.
I know, you get excited and think we're done, right?
Yeah, we need to add them.
We're going to add 2 over. And when we add 2 over, can we add them to the root 11? No, they're not like terms. I typically put them in front. And you'll see why starting tomorrow when we do 3.2 is because the quadratic formula usually has the constant in front and the plus or minus of that root in the back. So this will be v equals 2 plus or minus root 11. My pencil's going out on me, I'm sorry. Now we're done. And I know it looks really weird, and I was talking about this in my other class. Like, I feel like we're really judgy as people when it comes to numbers. Because you're like, oh my gosh, that number's so ugly. Like, would you ever say that to someone's face? Like, oh my gosh, you're so ugly. No, but we have no problem saying it to numbers. But this is an actual number. 2 plus root 11. Will you type that in your calculator, Riley, since you have it out? Just type 2 plus root 11 in your calculator and hit enter. Yeah, it's a number. It's ugly, but it's 5 point blah, blah, blah. And then 2 minus root 11 is a number as well. So we're really judgy because we like these nice whole numbers, right? But roots and radicals, they're all different types of fractions. That's what we were dealing with this morning. People hated the fractions, and they kept complaining. And I say, hey, what did a fraction ever do to you? Right? So the last thing is, oh my goodness, what do we do with a degree 4 polynomial? Well, actually, it really mimics our quadratic, where this is something squared, this is the square root of it, and this is a constant, right? Like if you look at all of these quadratics, the x was squared, this was the square root of x, and then we have a constant, right? So we actually can use the AC method this way. Keep x to the fourth. When you split up the middle term, keep x squared, and everything will work out, okay? So our a is 1. Our c is 9, so with factors of negative 9 that add up to 8. 9 and 1, which one's positive, which one's negative? Negative 1. So we're going to write this as x to the fourth minus 1x squared plus 9x squared minus 9 equals 0. So notice the first term, x to the fourth, stays x to the fourth. The second term, negative 9, stays negative 9. And then the middle term, when we split it up, we didn't split it up as x and x because they have to be like terms. Like when we add them, we have to be able to add them, right? Negative 1x squared plus a 9x squared is an 8x squared. So we're good to go. All right, so what we're going to do is we're going to take the square root of, or not the square root, excuse me, the common factor of the first two terms. What can we factor? X squared. You got it. And then remember when you factor him out, you're just kind of reducing his powers by that many, right? So if we had 4 x's and we took 2 away, how many remain? 2. If an x squared was there and we took them all out, how do we show he was there? A minus 1. Perfect. Back here, what can we take out? A 9. 9 divided by 9 is 1, right? But it leaves us with x squared. And how do we show that the 9 was there? With a 1. All right, so we're almost done. You're going to notice that these two terms have a factor of x squared minus 1 that we can factor to the front, and an x squared plus 9. And then we use the zero product property that we did in the beginning, where we're going to take each term, x squared minus 1 equal to 0, and solve it using the square root method. And x squared plus 9 equal to 0, solve it using the square root method. Okay? And both of these we can do because we now know of imaginary numbers and all that kind of stuff. All right? So according to what we just learned right above, if you have a perfect square, if you have a square and just a constant, you can isolate that, right? So we're going to add 1 over. So we have x squared equals 1 But how do you undo a square? Take the square root, and if we're going to put the square root there, what do we have to put in front? Plus or minus, okay? This is something that a lot of people, like in my 116 class, they would do this because this is kind of like a lesson we do in 116. They would just leave that as their answer. But what is the square root of 1? 1. So we can go further. And I guess technically they're not wrong, it's just not simplified at that point, right? So x equals plus or minus 1. What does that mean? It means if we plug in 1 or -1 into this left side, we'll get 0. All right, here we can do the same thing. We actually didn't see it before above, but we can handle negatives under square roots now. We know what to do with them. So I'm going to subtract 9 over. So we get x squared equals -9. How do you take care of a square? We're going to take the square root. The square root of x squared becomes x. And then what does this right hand stay as? Plus or minus is always in front, right? But then what's the negative under the square root pop out as? Pop out an I, right? And what's the square root of 9? 3. So this is just plus or minus 3i. And that's what's crazy, guys. You can actually check that in your calculator. Now that we have our calculator set to the complex number system, you can put in parentheses 3i, raise it to the 4th power, plus 8, parentheses 3i, raise it to the 2nd power, minus 9, and hit enter, and it'll give you 0, which is crazy, because before we would get here and be like, oh, can't do it.